No graphing in 8.5. Hooray. We are going to solve equations, all right? And then we'll have one problem kind of in the middle that is not technically solving. So we will start by solving exponential equations, all right? So that's like this one. We're going to do this using logs because the log will produce a way for that x to get out of the exponent. So what you're going to do is put a log right here and right here. So it'll be log of 7 to the 3x and log 20. We can do that because we did it to both sides. Now what can we do with that 3x based on our properties from yesterday? It moves to the front from the power property. This whole 3x becomes the coefficient. So it's 3x log 7 equals log 20. You with me so far? Our goal is to get x by itself. So how can we move that 3 and log 7 to the other side? Divide. Since they're all being multiplied, that is an easy way to move them. So they cancel over here. So we're left with x equals log 20 over 3 log 7. Now, what's the base for those logs? 10. It's the common log, which means you can put it in your calculator. So that's exactly what you're going to do. Get your calculator and put log 20 divided by parentheses around the denominator 3 log 7. And round your answer to 2 decimal places. And there you go with the first problem. So, 3 or 4 above on.
Right by 7.
Yeah, right by 7. Yeah, everybody needs a calculator. Austin, you have a calculator? Stratton, will you get Austin a calculator?
Is it
Oh, so
.89?
nice. No.
Is it .386?
No. There you go. 0.51. All right, let me come around and look and see what you did wrong. Okay, let's try the next problem. We're going to take the same strategy. So put log in front of both sides. What do we do with the x plus 4? Move it to the front. And that kind of, the whole thing is moving, so when you rewrite it, leave it in parentheses, or else it gets kind of weird. We can't move the 4 and the log at the same time because it's 2 different operations. The log is multiplied, the 4 is added. So let's move the log first by dividing it, and you can put that in your calculator. What's log 101 divided by log 3? X plus 4 equals 4.2. All right, now this basic problem, so just subtract 4. X equals 0.2.
Too easy.
Too easy. Probably the hardest part of that one is writing this with those parentheses, so that you kind of have a barrier between the 4 and the log. Any questions now? Okay, so those 2 examples get you through the 2 through 12 even on your homework. All right, the next ones I think are even easier if you're good with your calculator because we've done these before. you're supposed to solve this exponential equation by graphing. It's an equation, got a left side and a right side. Well, you don't have to draw a graph. You just have to, you're using the graph. Oh, come on. X equals Y, I think. So make this one Y1 and this one Y2 and find the intersection. You remember what buttons to press to do that?
Second intersection.
And then number 5 is intersect. You may have to change your Y max to be bigger than 1500. So just FYI. But you do second, trace, 5, enter, enter, enter. After you have them in Y1 and Y2.
Are we supposed to do this?
Yeah, you're supposed to do this. And tell me what the X equals rounded to 2 decimal places. Mm-hmm. You pressed enter and it paused it.
We can find out your X max bigger.
Yeah, bigger than 1500. So 1501 or 2000 or anything like that. Yep.
It won't let me get
Yeah.
off the graph.
Press enter. I think it paused it.
So where do we go?
So do second trace 5. Enter, enter, enter. Not X is your answer.
It doesn't give me the other, there it is.
There you go.
2,
2 point what?
2 point nothing, 4.
0, 4. That's where the intersection is. Anybody need help finding this? No good? So that example 2, the graphing one, you don't have to graph on your paper, just your calculator. That'll get you through the 16. So that's 13 through 16 off. Okay. This next one is the one where we're not quite solving, but what we're doing is we're going to use the change of base formula, that's right up here, to figure out log base 3 of 15. We're going to do this using our calculator, okay, and that formula. Then once we get that, we'll get like a decimal or something. Once we get that, we're going to convert that log base 3 to a log base 2. Okay, so this 3 will change to a 2, and the 15 will change to something else. All right? So our first goal is to figure out like what this equals as a decimal, which our calculator can help us do. I've written down these steps on the side, so we're going to use those. We're going to use the change of base formula first, which is right here. So our A is 3, our X is 15. Okay, so there's where the 15 goes, there's where the 3 goes. Now that B, we can make whatever we want. In order to put it into the calculator, what do we want B to be? What base can the calculator do? 10. So we want our base to be 10. So what that will look like is our original log will equal log base 10, you actually don't even have to write that, the 10 of 15 over log of 3. Why does that work? Because some really smart person figured it out, and now we get to use the shortcut.
They make money off of that, or
Probably. They probably made money off it. I don't know. Just guessing.
who would fund them?
I mean, if I would make the money, I'm not gonna waste my life trying to make a formula.
Who needs to help
I'm
people?
just saying.
All I need is money.
Okay,
There
so
are things we do to make no equation.
put that in your calculator. What's log 15 divided by log 3?
Yes, but we get short.
It is not log 5. $2.46 is correct. Do we need to round up?
No,
No, it says at 2.46. Okay.
2.5.
No, sorry, for the second decimal. All right. So that is the first thing. That is how you can evaluate a log by using logs. Yesterday? No, day before yesterday. Monday we evaluated logs using exponential form, and it was a long process that I don't think y'all really liked. So this one seems better. But now we got to keep going because we're supposed to convert this log into a log with base 2. And so let's write an equation for that. It'll be log base 3 of 15 equals log base 2 of, we don't know, so I'm going to put an x. Now what do we know log base 3 of 15 equals? 2.46. So we'll say 2.46 equals log base 2 of x. We can figure out what that x is if we get rid of the log. So let's put it in exponential form. So 2 is the base, right? What will the exponent be that's attached to that 2? Now? 2.46. Remember logs equal exponents? So 2.2 to the 2.46 equals x. Okay, put that in your calculator. We know what x equals. Five point something, I think. 5.5. All right. Last thing to do is just to actually write it as a log. So you'll do log base 2 of 5.5, and that is your answer. Definitely long problems. You have 1, 2, 3, 4 like that. But if you just follow those steps every time, you'll be fine. Okay, that's why it's really good for you to take good notes. Okay. Any questions? Let's go to the back then. Okay, now we are going to solve a logarithmic equation. So on the front, we solved exponential equations using logs, but now we're going to solve log equations. We can do this by math or by graphing if the log is base 10. So I'm going to show you both ways, and you can kind of choose how you want to do it. Let's do mathematically first. Okay. So first thing we want to do if we're doing mathematically is convert to exponential form. So what is our base? 10. If you don't see the base, the little number, then it's automatically 10. So 10 to the what equals what?
10 to the 3x plus 1.
10 to the 5. The answer to a log is always the exponent. 10 to the 5 equals 3x plus 1. What is 10 to the 5th?
More than 100.
It is a 1 with 5 zeros behind it. So that equals 3x plus 1. Can you solve for this?
Nope.
Yes, you can. Okay.
Minus 1.
Minus 1.
So,
99,999 equals 3x. Divide by 3. That's a lot of 3's. X equals 3, 3, 3, 3, 3. And that would be your answer.
Did you just know that from the process you've done, or did you do that in your head?
I just did it in my head because 9 divided by 3. Divided by 3. Oh, no. 9 divided by 3. You can also do that in your calculator instead of doing it in your head if you want. Okay, so the other method is by graphing. Since it's base 10, we can put it in the calculator. So log of 3x plus 1, well, you put that in y1, and then put 5 in y2, and find the intersection. Now, it's a really big x, so you may have to make your window larger, right? But you should get the same answer, exactly the same. It's also a great way to check yourself. That's a comma. Okay, never mind. I'm not going to write a comma because it looks like a decimal.
I know it is.
Anyone have questions about graphing these? Do that later. Okay. Okay, so these you have, let's see, 1, 2, 3, 4. You have 5 problems like this. Okay, so you can do them on the calculator or by hand. I think they take about the same amount of time. Yes, one more problem. It's like you didn't see it coming. No, on your paper. All right, we are going to use our log properties, that's the ones we learned yesterday, to solve an equation. Okay, so we have this equation, 2 log x minus log 3 equals 2. They're both base 10, so that's good, because that's easy for us to deal with. But maybe it would be easier if they were just a single log. So what can we do to get them together?
Divide.
We will divide them, but we need to move this 2 first. Where will it go?
X squared.
Behind the x is correct. The 2 is going to go to this exponent. So you have log x squared minus log
Minus 3 log.
3 equals 2.
I thought we were going to put 3 in front, but I thought that was an exponent.
Oh, no, that's not. Okay, now it's what y'all said. Use the quotient property to divide them. So that'd be log. Which one goes on top? Yep. X squared over 3 equals 2. Doing good. Can't put that. We could graph from here, actually. So you could try that. Or we can do it the mathematical way, which was to convert it to exponential form. So what's the base? 10. What's my exponent? 2 is the exponent. And that'll equal what?
Well, the other one was 100,000. This one's
A
a million.
million. What?
No.
What is your problem?
Smoke.
Okay, what's 10 squared? 100. Okay, so that equals x squared over 3. Okay, what should we do with the 3? Multiply it to each side. Okay, so we get that 300 equals x squared. Okay, how do we get x by itself? Square root both sides. Okay, so what's square root of 300? 17.32. Now, I don't know if you remember or not, but usually when we take square root of both sides, we put in a plus minus, right?
It's only,
We do.
it's only if it's negative. Like,
No. Okay, but for this one, we actually only want the positive number because look, we're taking the log of x and we said that whatever you're taking the log of cannot be a negative number or zero because that would make it be undefined. So it has to be a positive number. Okay, these, right at this point, that's when you can choose to do the math way or the graphing. Okay, so if you would have done graphing, whoa. If you would have done graphing, you would have put log of x squared divided by 3 in y1 and 2 in y2, and then find the intersection. It's a funky looking thing? Yeah, it probably is. Okay, but either way, you should get 17.32. All right, any questions? No? Okay, so that finishes out the assignment. So I think you have 3 questions like that. All right, you still...